In order to factor anything with an equal sign in it, it must be set equal to 0. So it looks like example A is already set equal to 0, so we can go ahead and start factoring by looking for the first thing, which is there a greatest common factor. It looks like all the numbers can be divided by 3, and we can divide each of them by x to the third as well. So we'll write that GCF out front, 3x to the third, and now we'll write the leftovers. So 3 divided by 3 is 1, and x to the fifth divided by x to the third leaves us with x to the second. Next, 18 divided by 3 is 6, 4 minus 3 is x to the first, and last, 27 divided by 3 is 9, and those x to the thirds cancel each other out. So we'll keep going and factor this. We can factor everything that's inside the parentheses. There's 3 terms, so we'll break it into 2 parentheses. X times x is x squared, and we need to find the factors of 9 that add up to 6. So positive 3 and positive 3 will work. Next, we're going to set each of these equal to 0. So this is sort of the step we've been skipping. But when we set that equal to 0 and solve it for x by subtracting 3 from both sides, we know we'll get negative 3. The same thing will happen over here if we set x plus 3 equal to 0 and solve it for x. We always skip this step, so it's okay. I'm just reminding you why it works out. So we get x equals negative 3 again. We also need to set this one equal to 0. So we'll write 3x squared equals 0. To solve it, we'll divide by 3 first on both sides. And 0 divided by 3 is 0. And we need to take the cube root of x, or in other words, you're thinking to yourself, what can you multiply together 3 times x times x times x so that it equals 0? And the answer is 0. So we have x equals 0, x equals 0, and x equals 0. There's 3 of them because it was x to the third. So, I think I copied it wrong right there. That should be x to the third up there. So we have 5 answers, this one, this one, this one, and those 2. And that works out nicely because up here the original equation was x to the fifth. And this right here is a picture of the graph. You can see that the graph touches the x-axis right there at negative 3, and it touches it right there at 0. So your answers are correct. Go ahead and try B. Make sure that you pay attention and set the whole equation equal to 0. So take a second and see if you can fix that. Hopefully you tried example B and you noticed that we have an equal sign right there. We can't have an equal sign right in the middle of the problem we're going to factor, so we will fix that by adding 36 to both sides of the equal sign. Then that whole side will equal 0, and the equation we'll factor will be x to the fourth minus 13x squared plus 36 equals 0. So we can try to look for a greatest common factor, but we can't divide all of these by the same number because there's a 1 right here. We can't divide them all by a letter because the 36 doesn't have an x, so we'll go ahead, since there's 3 terms, and try to break it into 2 sets of parentheses. So I'm thinking to myself, what times what equals x to the fourth? X to the second and x to the second. And that works out because x to the second is the middle term. Next, we will figure out the factors of 36 that add up to negative 13. So you should have come up with negative 4 and negative 9. They're still not done. We need to break them each into 2 sets of parentheses. So what times what gives you x squared? X and x. What times what gives you 4 and subtracts to gives you 0 x's in the middle? Positive 2 and negative 2. We'll do the same thing over here. We'll factor that into 2 sets of parentheses. X times x is x squared, And what times what equals 9, and when you subtract it, it gives you a 0x, which would be in the middle, but it's not. Oops, 3 and -3. So now we have our 4 factors, and we'll set each of them equal to 0 and solve for x. The shortcut is to write down that the first one's -2, this one will be +2, then we'll have -3, and then we'll have +3. If you would like to confirm that on a graph, you would be looking for something that crossed at -3, -2, +2, and +3. So something like that. Go ahead and graph it on a calculator. It should confirm your 4 different answers. We're going to learn about multiplicity so that when you get a problem like the first example, you don't have to list out the same answer 3 times like we did there. And even for that matter, we listed out that -3 2 times. So what we could do is just list the multiplicity. It's how many times we have the same factor. So for the first problem, we could have said our answer is x equals -3 with a multiplicity, I'll abbreviate it, of 2, because there's 2 of them. And then we could have said we have x equals 0 with a multiplicity of 3, because there were 3 of them. If you have only one of each, like we only had one -2, we only had one +2, and so on, then you would say that each of them had a multiplicity of 1. And if you didn't want to write it out for all of them, sometimes I just put a little bracket and show they each have multiplicity 1. So why do we have to talk about multiplicity besides to help us save time writing our answers? It actually helps us figure out the shape of the graph. If you have an even multiplicity, so if you have 2, 4, 6, or 8, and so on, of the factors, it means your graph is going to touch the x-axis, but then turn around and go the other way. So something like that, or if it's above, it looks something like that. If you have an odd multiplicity, greater than 1, so 3, 5, 7, etc., the graph will bend when it goes through the x-axis. So it might look like that or that. So let's look at this graph right here. It's the same graph as the answers for example 1a. Remember how we had 2 -3s for our answer? So 2 is even, which means that the graph would just touch the x-axis at -3, and sure enough, that's what the graph did. And remember how we had 3 zeros? Since the multiplicity was 3, and that's odd, the graph would bend at 0. And sure enough, you can see right there at 0, the graph bends. So it really helps us figure out the shape. And we will do more with graphing them, so that's just another piece of information. So let's go ahead and factor these, get the roots, and then we'll state the multiplicity. We need to make sure that the equation is set equal to 0, and it is. So we're all set to try to see if we have a GCF. And it looks like we can divide everything by 2. And as far as the variables, x to the 4th. So we'll divide each of these by 2x to the 4th. So we write that GCF out front, and the leftovers we'll write next to it. So 2 divided by 2 is 1, and 6/4 leaves us with x to the 2nd. Next, we have -10 divided by 2, so -5, and that reduces to x. And last, -12 divided by 2 is -6, and the x to the 4ths cancel out. So we'll recopy the 2x to the 4th, and we'll try to break this into 2 factors. We have 3 terms. I know x times x equals x squared, so our job is to find the factors of 6 that subtract to get -5. So the factors of 6, 1 and 6, 2 and 3, a lot of people might think at first glance to use 2 and 3, but we can't subtract 2 and 3 to get -5. We would only be able to get 1 or -1. So we'll go with 1 and 6. If we do 1 minus 6, that'll give us our negative 5. So we'll put a positive 1 and a negative 6, and now we set each of the factors equal to 0 and solve them. So this first factor will be negative 1, this factor will be positive 6, and when we set 2x to the 4th equal to 0, we could do all the work, but basically the only number that we could put right there for x is 0. The question is, how many zeros were we multiplying together? 4 of them. So instead of listing a couple more x equals 0, we will put that it has multiplicity 4. So there's one answer. There is only one x equals negative 1, so we say that has multiplicity 1. There's another part of the answer, and there is only one 6, so that has multiplicity 1 as well. You know you're done counting up your answers if you have, let's see, we have 4 plus 1 plus 1. So we have 6 answers altogether, and our degree was 6, so we're good. Go ahead and try B, and we'll see if you did it right. So did you check to make sure that your equation equals 0 before you started? Hopefully you noticed that that equal sign is there, and you can't just start factoring something with an equal sign 3/4 of the way through it. So we will fix it by getting rid of the minus 50, and we'll add it to both sides. So we will be working with x to the 3rd minus 2x squared minus 25x plus 50 equals 0. So we're going to try to factor it. We could look for a GCF, but we can't divide all 4 of those by the same term. So our options are to chop it in half right there. Remember to chop it in front of the negative sign. Or we could unbox it. I'm going to go ahead and unbox it. You'll get the same answer if you group it. So I'll put each term in the boxes. Don't forget to copy the signs in front, and now we'll look for the greatest common factor in each row and then each column. So the top row, the GCF of x to the 3rd and negative 2x squared is x squared. In the bottom row, first I see that negative, so I'm for sure going to take the negative out, and you can divide both 25 and 50 by 25. Now we're going to look down the rows this way. So the GCF of x to the 3rd and negative 25x looks like just x. And then this column right there, that negative's first, so we need to for sure pull that out. And the GCF of 2 and 50 is just 2. So the factors are x minus 2 and the one from the side, x squared minus 25. If we pay attention, we can see that that last one is not completely factored, and it needs to be broken up one more time into x times x and plus 5 and minus 5. So now setting each of those equal to 0, our final answers will be x equals positive 2, and then x equals negative 5, and x equals positive 5. Each of those answers only appears one time, so you would need to label that each of them has a multiplicity of 1. And you could graph it on the calculator to check your answers. Your graph would go through negative 5, 2, and 5.